Hello everyone. So in this video we are going to do binary classification using machine learning algorithms. I am creating separate video for each machine learning algorithm so that we can grasp the concept and then can implement them using Python, so we have a better understanding of how the concept actually works and how we can implement it for classification based problems. So in the last video, I covered this data set, how we can acquire it, upload it on Kaggle, how we can pre-process it and get it ready in the form of a training, validation, and test set so that we can feed it into the machine learning model. So I'm going to link this video in the description below and also add it over here as well if you want to go and check it out and prepare your data set and come back here so that we can start this binary classification. Okay, so the first algorithm that I am going about in this video is the k-nearest neighbor algorithm. This is a supervised algorithm for classification, and it is a distance-based algorithm, meaning that it takes into account a distance from one sample to another. So to better understand this, let's take an example. In this example, we have an income of a person per year and the number of children they have. So for example, if a person has an income of 40,000 per year, he has a one child. So for example, he has only one child. So for example, if a person has 120,000 pay per year, he has one child. Based on this data set, what we are doing is basically this data set is already labeled. So one thing that we need to keep in our minds is that in k-nearest neighbor, the data is already labeled, meaning that we have the data sample and then their associated categories or labels as well. So in this data set, we have two categories. First one is the plus, meaning that a person owns a car, and second is minus, which indicates that the person does not own a car. So for example, we have this data point over here, and we have to classify this data sample based on all these data samples that have already been classified, categorized. So by when we are using k-nearest neighbor, what we are basically doing is that we are calculating the distance between this data sample and all the data samples in the data set like this. So for example, we calculate the distance of this point to this point, then this sample to this sample, then this sample to this sample, and so on. We repeat this for each and every data sample in this graph, for example. And what happens is that how we calculate the distance in the k-nearest neighbor, basically it calculates the distance by using Euclidean distance. So let's go through the concept of Euclidean distance first so that we better understand how it actually works. So Euclidean distance looks something like this, where for example, if we have an x-axis and a y-axis, y is over here and our x is over here. So for example, what's happening over here is that we draw a line, and in this line, this would indicate x1, this is our x2, this is our y1, and this is our y2. And we have these values. For example, for this point, we have x1 and y1, and for this point, we have x2 and y2. So to calculate Euclidean distance, this is the formula basically where we subtract x2 from x1 and y2 from y1, and then we take the square of it and put it into a square root. So this is generally the formula of Euclidean distance. What it does is it helps us to calculate the distance between this sample and all these samples, and then we have to select the one that are closest to us. So how do we select the closest ones? For example, after we are done calculating the distance, we see that the value of k is equals to 3, for example. This means that we have to take the 3 closest neighbors to this data sample. So if you look into this graph simply, you can see that the samples that are closest to this data sample is this one, and this one. These 3 are the closest one, and as we can see, all 3 belong to this class, which means that the person doesn't own a car if his salary is around 40,000 and he has 2 children. This means that this data point will also be minus. Okay, so this is the basic concept of k-nearest neighbor. To better understand this, I have added another example for you before we head on with the implementation. So for example, I found this really useful example on the internet, and I thought it would be really beneficial for us to cover this as well. So for example, in this data, we have the IMDb ratings of these 4 movies along with their duration in hours, or in minutes, and then their genres. So for example, 2 movies belong to the horror genre and 2 of them belong to the comedy genre. Now we have to classify this Barbie movie, which has this IMDb rating and this duration question, and we have to see in which category this Barbie movie would fall in. So based on k nearest neighbor and what we have just discussed, step 1 is to calculate the Euclidean distance between the Barbie movie and each movie in the data set. So the Barbie movie has these attributes, so we have added these, and we have to calculate the distance of this one with these. So for example, 8.0 and 160-minute duration is of this unholy movie. We'll put this value in the equation x2 minus x1 ka square plus y2 minus y1 square root, and then we calculate the value for each of the data sample like this. Once we have done this, the next step is to see what is the value of k. In this case, the value of k is 3, which means that we will consider the 3 closest neighbor to the data point, to this data sample. So for example, this is closest, and then this one is closest. So if we go back and see, the first sample belongs to the horror genre, the third sample belongs to the comedy one, and the fourth sample also belongs to the comedy genre. So here's what I've written over here as well. So now the third step is to do majority voting based classification. So when we do this, we can see that we have 2 movies from the comedy genre and 1 from the horror, meaning that this has more weight compared to this category, right? So the Barbie movie would also belong to the comedy genre. So this is how k-nearest neighbor works. So going back to how the code of this works, if we go back to the coding, as you can see, the coding of this is pretty straightforward. You just have to add a few lines and your code will be done. So for example, in the first line, you can see I have imported the kneighbor classifier from the sklearn.neighbors library, and then simply we have to identify a variable. In this case, I've named it knn underscore model, and then I used this one over here, and n underscore neighbor is basically the value of k, which we just discussed. In this case, I set the neighbors to 1. You can obviously go ahead and change the neighbors and see what effect it has on the results. And finally, to apply this model and to train basically the machine learning model, we need this fit function. So we simply give the x train and y train, where x train is our 10 features and y train is the category or the label, and then we give it to the fit function. It would simply run and fit the model accordingly. So now the model is run, for example, it has done all the fitting and training and everything. Now we need to make a prediction on test data set or unseen data. So for example, if I hit run on this, as you can see, it looks something like this. And this is the true prediction of our or the ground truths of the data set that we already know, and this is the one that our model has predicted. So as you can see, it has label 1 over here, label 1 over here as well. It only misclassified one class, which is this one. It classified it as 1 and this one is 0. So to better understand the results, we can also see the classification report, which provides us with information about different performance metrics, including the accuracy, F1 score, and everything. So we can simply use this library sklearn.metrics and import this classification report and simply run this. So if we run this, we get this entire classification report where we can see the accuracy is around 81% and the precision over here for each class is given and everything. So if we want to get some better visualization of it, we can also plot the confusion metrics, which would provide us with insight of exactly how many samples are correctly classified and how many of them are misclassified. So for example, if I run this, you can see that that the samples that are correctly classified as gamma, and they were already gamma, were 2162. The samples that were misclassified were these ones, and the samples that were actually hadron and also predicted hadron were this 922 samples. So this is basically how KNN works in its simplest form. It is not very difficult to implement or understand. Once you understand the concept, you can easily implement it and use it in different ways to get different results. So I hope you found this video useful. I'll see you in the next one. Thank you so much.